Howdy rock buds, Papa here. Let's look at some more rocks from the old rock pile, and we're going to start with the easy ones. So here we go. Okay, here's our first rock to identify. Let's just have a look at it. Right off, I can tell there's some of this Mira stuff. What could this Mira stuff be? Right, Mira muscovite. So we've got a lot of muscovite in here. There's another. That might be biotite, but what else we got? More muscovite. I can see clear pieces of a mineral that's clear or gray here. A lot of those clear gray specks in this white stuff. And what do you think that is? Right, that's quartz. How about the white stuff? Well, let's look over here because there's a big white stuff, piece of white stuff. Where'd it go? Where'd it go? Where'd it go? Oh, yeah. Right here. A big flat surface. And I don't know if you guys can tell, but it's got a flashy face on it. A flashy face. What do you think that is? Right. Some kind of feldspar. Look at this big old plate of muscovite. There's probably, I think there's biotite in here too. Right here, that might be biotite. Black biotite. So we've got quartz. We've got muscovite. We've got a lot of muscovite. We've got some biotite. We've got, excuse me, a lot of feldspar. And the feldspar is white. So I'm going to say it's probably a combination of potassium feldspar and sodium-rich feldspar. Okay. So, incidentally, a very common rock called granite has these same minerals in it. So, what do you think this is? Could it be a granite with some big mineral crystals? Yes, it could be. And what would that be called? There's a flashy face on the feldspar. That would be called granite pegmatite. Okay. Where do granite pegmatites form? Granite pegmatites can form on the edges of granite plutons, where granite plutons intrudes into a host rock and heats up the host rock, and that causes it pulls the molten magma pulls in minerals from the host rock and makes them grow big. That would be an example of contact metamorphism. Another way is in a granite a granite magma mix that is rich in what we call volatile elements. Lithium is one of those volatile elements. Water is one of those volatile. It's not an element, but a molecule. And those volatile members encourage the growth of big crystals. And if they're exotic, excuse me, elements like beryllium, you can get beryl and aquamarine and even emerald. Okay, so we got a granite pegmatite. Beautiful. I love this. Okay, this is rock number 2. What do you see? Let's just take a look. It's kind of a rusty, reddish, orangish weathering rind on it. So that tells us there's iron in this rock. It's pretty heavy. And what do we see here? We see a black mineral and a white mineral. And the black mineral, is it biotite? Doesn't look like biotite, but if I take a nickel and scratch it, which I'm not going to do because I don't know where my nickel is right now, the nickel will not scratch it. The nickel's about a number 4 on the Mohs hardness scale. Biotite is around that too, maybe 3.5, 4. So if it's not biotite, if that black mineral's not biotite, what could it be? What are our choices? Okay, another black mineral is tourmaline, but tourmaline almost always occurs in very felsic rocks. And you probably figured out this is not a felsic rock because it's dark. And we don't see muscovite, we don't see flashy faces of potassium or sodium-rich feldspar. So this is probably it's not an intermediate rock like biotite and gneiss because it doesn't have biotite in it. So it's a mafic rock, right? Okay, so I figured out it was a mafic rock because it did not have the felsic minerals, a lot of felsic minerals like quartz and pink feldspar or white flashy face feldspar. And it doesn't have biotite in it because this black stuff doesn't scratch with a nickel, so that tells us it's a mafic rock. So that's got us down the road pretty far. Next thing I notice, what are the possibilities for the black mineral? Not tourmaline. So we've got hornblende and pyroxene as possibilities. And we're likely looking at some of both hornblende and pyroxene, probably mostly pyroxene. So we got a mafic rock with a lot of pyroxene, and how about this white stuff, this white mineral? Well, this white mineral, you'll notice it's not like flashy feldspars, which is potassium feldspar and sodium-rich feldspar. They have flashy flat faces on them, but if this is feldspar, which it is, it's arrayed in these stringy, shreddy kinds of streaks. And you know what? This patchy, stringy, shreddy kind of white stuff is a sign of calcium-rich feldspar. Calcium-rich feldspar does that as opposed to sodium-rich and potassium-rich feldspar, which both have flat, flashy faces. There are no flat, flashy faces here, although I do see a little bit of shiny stuff right there, but that's black. So we got a mafic rock with lots of pyroxene probably and calcium-rich feldspar. So what are the choices for this rock? Okay, mafic rocks, it could be diabase, which is a mafic igneous rock. But it doesn't look like diabase to me because diabase is mostly dark and it's crystalline looking. And this is not crystalline looking. This is had a lot of weathering done to it. And another thing I've noticed, okay, so we're talking mafic rocks, basalt lava, gabbro-pluton, and their metamorphic versions, which would be amphibolite. So I'm seeing big crystals. Now, what does that tell us in a mafic rock, or any rock? If you see big crystals, that means that this rock was formed probably pretty deep underground, and it cooled slow. That allowed it to cool slowly so that big crystals can form. So what mafic rock forms deep underground and has big crystals? If you guessed gabbro-pluton, you would be exactly right. This is gabbro. It's actually gabbro. It metamorphosed gabbro. And where does gabbro come from? Well, it comes from a lot of places, like in rifting situations, you get a lot of mafic magmas and lavas, and so you can have gabbro deep underground, and when the gabbro reaches the top, you've got basalt lava. Gabbro is also a major component of ocean crust. Ocean crust is layered, and on the bottom layer you have a big pool of gabbro, and that gabbro squirts up at a mid-ocean ridge into the water and becomes, once it reaches the surface, it becomes basalt, columnar basalt. It forms these big columns, columnar basalt. So gabbro is the underground version of basalt. Basalt is the above-ground version of gabbro. Also, diabase, which is an underground version of these two mafic rocks, but it usually forms very much closer to the surface than gabbro, and you can tell that because diabase has smaller crystals than gabbro, and basalt, you can't even see the crystal structure there because it flows out and cools very quickly. Okay. Subduction zones as well. Subduction zones produce felsic, intermediate, and mafic lavas and magmas, and gabbro is one of those magmas. Probably there's a lot more felsic and intermediate lavas and magmas in a subduction zone than the mafic magmas and lavas, but nevertheless they do form. Okay. This came from the fault that we call, in Georgia we call it the Middleton-Lounsville Fault, where the Carolina terrain was mashed onto the Cat Square and Inner Piedmont geologic terrain. Okay. And why this red rind? Because both these minerals, pyroxene has a tremendous amount of iron in it. Okay, gabbro. Okay, now for a rock. This is a hard one, difficult, but it's very pretty. What color do you see a lot of? That's hard to tell. Well, that doesn't help. I get it close. What's a major color that you see in this rock? Yeah, a kind of a bluish green color and some shiny silvery color. You know, your computer screen uses several colors to project everything on the screen. Mixes of these colors. We've got magenta, we've got cyan, what else we have? I forget. But magenta and cyan are two, and blue is another one. So this color actually is cyan. It's kind of a lightish blue color. And does that trigger in your mind a name related to cyan, like cyanite or kyanite? Yes! You got it, bros. This is kyanite. The mineral kyanite. It's really pretty stuff. It's got it can flash its face there, and that's a pretty cyan example of a crystal face there. Where does kyanite form? Kyanite forms in very powerful high-pressure hydrothermal situations. And what am I talking about? They would be mostly associated with subduction zones where, let's say, ocean crust is subducting beneath the land crust, creating all these volcanic mountains. And there's ocean water involved, and deep down in the earth, there's a lot of pressure and ocean water. You get these hydrothermal vent areas under high pressure, and kyanite is one of the cool minerals that can form. And so if you see kyanite in a rock, then you know that that rock very likely formed under very high pressure and in a hydrothermal situation. What do I mean by hydrothermal? Well, hydro means water, thermal means hot, so hot water where ocean water goes down deep in where the volcanic magma is in a subduction zone. It picks up minerals, elements like kyanite, gold, silver, etc., and brings them up and flushes them into the sediments on the flanks of these underwater volcanoes, and kyanite is one of those. Kyanite was in high demand back during World War II because they used it to make airplane spark plugs, the ceramic that composes airplane spark plugs. So it's very heat resistant. And I've seen these videos where they take spark plugs and they use the ceramic of spark plugs to cut glass. So kyanite that shows you how hard kyanite is. I don't know what its hardness is. This kyanite came from a place called Graves Mountain, which is near, it's near Athens, Georgia. It's east of Athens, Georgia. It's in the Carolina super terrain, geologic terrain, and the Carolina as you guys know, the Carolina super terrain started out as a volcanic microcontinent back during Devonian time that crashed into North America way up high, New York, Pennsylvania, even higher up. It offloaded all its sediments in what we call the Catskill Delta, and those sediments are now part of the Catskill Mountains up in that area. And then it slid along different faults, including the Brevard Fault Zone, down here to Georgia. And it brought its kyanite with it. So kyanite. The Mount Mitchell, which is the highest point in elevation east of the Mississippi, pretty close to 7,000 feet above sea level. The reason it is that high, and the associated mountains, the Black Balsams mountains are associated with them, called that because they got a lot of Fraser fir and spruce, which are dark evergreens. The reason those are the tallest mountains east of the Mississippi is because the quartz muscovite schist that they're composed of is full of kyanite. Kyanite is really hard and weathers slowly, so those mountains were pushed up during Taconic or Acadian, probably Acadian, as the Carolina terrain slid south along the Brevard Fault Zone. And the kyanite in them caused them to weather and erode slowly, and so they remain very high. So, kyanite. Okay, our last rock for the day. This is the hardest of all, but I can tell you it is associated with Graves Mountain hydrothermal area and the kyanite. So I'm just gonna. Well, what do you see? What color are we looking at? Yeah, kind of a pinkish color. And there's some whitish specks in there. This is a crack side. Let's see. Here's what the other side of it looks like. Geologists didn't know what to call this for a while. They called it quartzite. And that's not a bad call for it, but it's got more than quartz in it. Since it came from a hydrothermal area, what would you say about the pinkish color? Yeah, if you said iron pyrite, you'd be right. You'd be pyrite. Iron pyrite is iron and sulfur put together, and those are both elements that come up from volcanic vents, black smokers, whatever you want to call them. So there's a lot of this iron pyrite staining in here. You've got quartz, but mostly you've got pyrite and the white stuff is cerussite, which is a form of cerussite forms when muscovite mica is exposed to a lot of water, especially hot water. And once again, you have kyanite in there too. Can't see the blue color of kyanite, but Dr. Gilles Allard, one of the great geology professors at the University of Georgia, who's now with our Father in heaven, who I admire and loved greatly. He calls this a pyrite, cerussite, kyanite granophyllus. A granophyllus is a rock that has kind of a uniform texture to it. You don't see a lot of crystals in there. So this is also from Graves Mountain, a product of hydrothermal metamorphism. Okay, there you go. Okay, most excellent rock buds. Those are the 3 rocks for today. Hope you guys have a great day. Thanks so much for watching. This is Rock Papa saying, happy rock hunting. Pop out.